For me, it's like 5:30 a.m., so sounds like a good time for start. Welcome, everyone. I'm Michal Kordas. I came to you from Kraków, Poland, and I work in Luxoft as a QA, but my main role is not to test the quality into the software at some late stage of software development. It's rather to build quality into entire process, as I believe that software with really good quality doesn't emerge after like sufficient amount of testing. Rather, it needs to be built with the quality from the very beginning. So having great requirements, having great code that is maintainable, that is readable, then having proper release and deployment processes, and proper feedback loops working all the time, getting us the knowledge whether what we coded actually works properly. And today I'm gonna talk about three topics: BDD, Groovy, and Spock. So enough chit chat, and let's go into the things. That's a typical Apple product: white cover, one button, and people sleeping on the streets in front of iStores, just begging to get a new iPhone just after releasing. This is typical Google product: one text field, one button, and billions of queries every day, billions of dollars of revenue every month. And this is how our products look like: mess, complexity, a lot of strange things going on, and that's our daily life. But is it rocket science? We, in fact, are usually not sending any rockets to the moon. Yeah? So our applications usually are just business applications that do some logic, and they are not really complicated, so they are not hardcore. Yeah? While on the other hand, we all know that picture. I do not need to describe it what is inside. We all have some miscommunications problems, some things happen that we do not deliver what is really needed. It appears that the only real problem, the only challenge in our software are not the technology problems, because we are smart guys, we can use whatever technology we like, we can really do really great things with software. But what challenges us is to understand the problem really well, what we are trying to solve. In order to create software that matters, first of all, we need to see us reaching the goals. We need to understand what are the purposes of the things we are doing, what are the goals, what are the aims. And these are the things that business people are good about. So they see the whole picture of the things, and they're floating somewhere between the skies and space. And for us, those guys are strange creatures, what they are talking about. But ultimately, our current work, our tasks, do not matter much without those goals. So we need to somehow find a way how to convey in what we do those things, so that what we create is really used, is just mattering for someone. And how we can guarantee that what we do is fine? Of course, by some kind of verification, yeah? And when I was in university, the great verification tool for me was Java-C tool, yeah? So it compiled, it works, it is ready to be shown to lecturer. But we are all responsible guys, and we test our software, yeah? Otherwise you wouldn't be on that conference. We know that testing is crucial. Compiling is not enough to verify that what we coded works. So we do unit testing. But that's just basic verification. The more advanced technique is to do test-first approach, where we begin with verification for our code, and our code is just written to fulfill that verification, so that our feedback loop is really fast. Actually, it's negative. So we write the code, and immediately we know whether it is all right or not, because our tests lead us in the proper direction. And even next step, is TDD. And what's the difference between TDD and test first? It's pretty crucial, because in test first, our tests lead the code creation, while in TDD, our tests lead code creation, of course, but they also lead the design. Because in TDD, we have refactoring stage, which is very often forgotten. And then there is no difference between test first and TDD. But in TDD, there is a lot of pressure on heavy refactoring after each cycle, where our design emerges. So the first unit testing framework was JUnit for Smalltalk. But Smalltalk was quickly forgotten in the industry, and it was replaced by JUnit, CPP unit, PHP unit, and all the XUnit frameworks. And I would say that this framework did one bad thing. They have unit in their name. And they kind of suggest that you should do unit testing, that TDD is about unit testing. But originally, the idea of TDD was testing, not unit testing, and that's a huge difference. Because XP programming was from the very beginning about acceptance tests, customer collaboration, and so on. So this unit kind of misleads us to the direction of thinking about technical tests, but it's not limited to it. And at some point of time, Dan North had to come and say, come on guys, you are not doing TDD in the proper way. These high-level tests are also important, and they were in the nature of TDD, but this was spoiled by these JUnits, XUnits, where you thought about only unit testing. And you should have the broader scope and think also about all levels, all kinds of tests. So tests, not unit tests. And Dan North said that, of course, the specification we write needs to be understandable for developers, and that's pretty obvious because we are smart in what we do, and we understand what non-technical people tell to us. But the second point is much more challenging. So Dan North noticed that what we say also needs to be understandable to non-technical people. And that's a must to have this magic happening between those two words, I would say. And specification, of course, should be unambiguous for both sides, and they should be run really frequently, because we want what we do to work not only right now, but all the time, now and in the future. Dan North proposed to use Gherkin language. And Gherkin language, you may know that word from London if you're a traveler. This is Gherkin in the city of London. Or if you like more Slavic climates, this is Gherkin too. And what it is just language consisting of three main keywords. Given where we set the state of the word, we list our preconditions for our specifications. Then we have when step, where actual behavior happens, where stimulus to the system happens, and in the then, we expect some results. Basically, we perform assertions there to verify that what we tested works fine. Dan North also proposed JBehave framework, so he came with ready solution for those higher level tests. And in short, this JBehave is composed of three parts. Plain text description of what we expect from our apps. It's just a scenario title given when steps, and pretty important part that is also missed from time to time is narrative, where we talk about whys. Yeah? So those things are about what's and how's. Yeah? And it was also forgotten in original JUnit that no one was mentioning why. Why we want some behavior to happen, why it is important for someone, what are benefits. And these are those purposes that we are talking about. We need to have them visible so that we are on the same page. These are the things that we are doing right now, and this is our goal. We need to have a goal to have a success. The next part is Java code that is binding between those plain text scenarios and Java code. So the main difference between JUnit and JBehave is that in JUnit we drive test execution by test methods. In JBehave we drive test execution by this plain text file, but underneath these are those Java methods. So each line from this file is taken, and proper line, corresponding line is found in Java code and executed. So this plain text file, step by step, drives execution of the story file. And underneath it's just plain JUnit. So there is no much difference. You can use JBehave as a replacement for JUnit. You can mix them together. That's pretty convenient. And we also need to configure JBehave, and that's the bad part, the nasty part. Usually that much of configuration is needed to make it working, and if you try to Google how to do it, and every page will tell you to do it differently, so there is no one unified way. In general, it's very configurable, but that's not a nice thing to do, as you need to go deeply into the things how JBehave works to make it working properly, but at least it's just once. You do it once for an entire project and you are done. Looks like JBehave is a pretty cool framework. When I joined Luxoft, I noticed that they use a lot of it, and they are proud of it. Yeah, we are using JBehave, we are trendy, we are following BDD principles, and that's great. So then I started talking with people about this, and I was pretty excited. Yeah, okay, you do it, you should be happy, and so on. While in fact, the developers in the teams I was working with, they were not really into that things. So they considered JBehave as a pretty terrible thing. So I've never met a developer that was happy, okay, today I'm gonna write some JBehaves. It was rather last task that was postponed, that was left on the whiteboard for a long time because no one wanted to take it, as it was not pleasant for those guys. So then I started asking many questions. Why you don't like this cutting-edge technology? It was created by Dan North, and you have it in your CV and you are proud of it, yes? What's wrong with it? And I started collecting the reasons, kind of pins that were going and making JBehave not so good solution. And the first reason was that whenever a developer needs to work on those, they have two separate files. So ideally, they would need to go into split view and modify both files at the same time. So any change in one file impacts the another file. So it's not convenient just to switch between those and work on these scenarios. So because these files are very tightly coupled. So changing some characters in one file forces you to change things in the other. Then, as Java developers, you probably use IntelliJ and you press Shift F6 very often, yeah, to change names of your methods, classes, whatever. So if you try to press Shift F6 in JBehave, it doesn't work even with the plugins for IntelliJ. And that's not what we like. We like smart things. We like refactorings. We don't want to do those things manually. Then with JBehave, the huge overhead is connected because we need to maintain those two files, and it doesn't make sense to use JBehave on lower levels. As testing parameter says that you should have small amount of system level tests and a lot of unit tests. So if you had to write a lot of unit tests in JBehave, this would take majority of your time and you wouldn't write that much code. You would be just writing scenarios. So that's why this is suited mainly for system level where we have low amount of them. So up to hundreds, but if you had to write thousands of those, it would be too much to handle. Then those story files at some point where we start to describe not only the main scenarios in our system, but all the cases, all the like different things that may happen in our complex systems, they start to look pretty dull. So probably you don't see much what is going on here, and that's on purpose, because that's how they start to look for the people. Whenever they contain more information, more scenarios, more narratives, it's all become blurred and not visible, not readable. Another pin that goes into JBehave are those parameter converters. So the plain text file description doesn't know anything about types. And Java is a strongly typed language. So whenever we have parameters in those JBehaves, we pass some parameters to our tests, they need to be converted into type-safe objects in Java. In order to do that, we need to have parameter converters. And this is the sample how to convert true and false into the proper Boolean objects. So a lot of boilerplate code just to do such simple thing like convert true and false to the Java's true and false. So at some point it also becomes a pain to provide such converters for every type of object we may have. Then whenever we parameterize those scenarios, under the hood, those parameters are replaced by .star, so greedy, regex, matcher, and those steps are matched by regex. So you need to have regex processor running in your mind all the time in order to understand well how those story files match to Java code. So at some point it also becomes risky, and this greedy matcher may not be as intuitive as you may imagine. So at some point we noticed that only developers written those story files, and we made an experiment. We said, okay, to our analysts, please provide for us those specifications, and it was working for some time, but then we realized that those analysts use too rich language. So they wrote beautiful story files with this description how our apps should work, but those beautiful descriptions were not corresponding to the testing framework that much, because we either needed to write the same step many times because they used different words for the same step, as this was better English sentence, or we needed to have many aliases. Yes, so the same thing like send message was written in many different ways to have the proper sound in English. So we needed to bind it. So we had huge complexity just connected with those analysts' language. It appeared to be more efficient just to delegate it to developers. So developers understood what is the existing framework, what are the steps available, what are the consequences if we try to increase the complexity of it, because it's all the code underneath. Yeah? So if they understood well what's underneath, they could propose some steps that would be easily to automate in that frameworks. But of course, those developers dislike it. That was not the stuff they wanted to do. And the biggest failure in our case was that those business people were not reading those story files at some point because they were dull, because they were complex, because we had too many of them, and we didn't find a way how to convince them that this will give some benefits. So instead of reading those, they were calling us, talking with us. They find it more convenient. So the original idea of those BDD and collaboration by automated high-level tests was broken. And it appeared that tools designed for non-developers were used only by developers. So definitely was something wrong with it. We did huge overhead for nothing. At some point, my teams and even me started to think that BDD tools are crap. Yeah, they do not bring anything, considering all the above. So what we can do at that point? Yeah, use it and suffer, or maybe have some other ideas. So the first idea that was proposed by many people in my team is to abandon JBehave. Yeah, as only developers write those scenarios, as they are read only by developers, why not use JUnit? JUnit is the language of developers. We can perfectly fine use JUnit to describe system behavior, despite unit in their name. So this suggests unit testing, but we can use JUnit to whatever test we like. Of course, JUnit has this camel case, yeah, but as Java developers, we are very proficient in reading camel case. We could have books in camel case, and it would be no problem for us, as we are good in that. We can even have comments if you really want to have those given when then. We can have it in JUnit tests and proceed. That's perfectly fine. If we don't like comments, we can even name methods appropriately. So given something, when something, then something, and this is pretty much equivalent to JBehave. That is just a code. We don't have these two files. It's one file, and developers should love it because refactorings work here. Many things that they use every day is here, like in normal unit tests. So this would be example of the nice JUnit test. And I chose parameterized test. And this test describes vending machine. So it verifies whether if we insert some particular coins to the vending machine, the amount, the credit displayed is the proper. So what we have here is that we have these parameters, a method of parameters that return collection of array of objects. Then we declare two-dimensional object array. Then we instantiate three-dimensional array of bills, where we provide two-dimensional array of $2 and two-dimensional array of $5 and $10. Yeah, as we like immutability in Java, we return immutable list of it to the test. We everywhere have final keywords, also for immutability purposes. We have pretty nice name with should do something when something happens notation. We use Hamcrest matcher, which actually really well explains our assertion. So if we insert get credit, something is equal to expected result. Pretty expressive way of making assertion. And you may think that's beautiful, and then you would be in the camp of people that are spoiled by JUnit. Yeah, if you think that it is nice and readable and beautiful, then you are the camp of people that are totally spoiled by Java. Or you may think otherwise, that if you are virgins, you are not spoiled by Java, and you you have fresh mind, you will see that this is pure noise. Amount of information in this test is less than 40–30%, and the other things are just keywords, yeah, some language decoration, and I don't know what happened. Like my presentation disappeared right now, so I need some help. Maybe it was disconnected. Okay, now it works. Okay, so let's go back to this test. And in fact, the amount of business knowledge conveyed in the test is just it. Yeah. So given vending machine, if I insert $2, then I have $2 credit. If I insert 5 and 10, I have $15 of credit. So compare this to this one, and this is exactly the same in JUnit. So the signal to noise ratio is huge. To make things worse, such JUnit tests are really sad, especially if you use Hamcrest matchers. Yeah? You may notice it in your tests. Yeah, each is really sad. So what we can do? What we can do with that? Either go to JUnit, yeah, and be in jungle of those noise. Choose JBehave, which we already spoke about, and it has many of problems with it. Or maybe there is third way. And I like to introduce Groovy language, which would be helpful to discover the third way that I want to talk about today. Groovy is dynamic language. So some people, when they see it's dynamic, they run away immediately. They like Scala, Java, which are strongly statically typed, and they don't want to hear about anything else. But in fact, Groovy can be statically type-checked if needed. So we can decide whether we want it safe or it's not necessary in that context. So it is optionally typed and strongly typed at the same time. You may think, okay, that's a mistake in my slide. It's contradiction. Language cannot be optionally typed and strongly typed. These are two distinct things. But to understand it, we need to see the difference. What does strongly and what does statically mean? So let's take Java, where if we try to divide 1 by string 2, of course it doesn't compile. We get a compiler error, just operands are not compatible with each other. It's obvious mistake. Then if we take C++, we may notice that types are not strictly bound to their objects. So we can cast, for example, string to some pointer to integers, then we can extract it and do the division, and this will compile. So C++ is statically typed, but not strongly typed. We can change the type of the things during runtime. Then we have JavaScript. And what's the answer? What's the output of this in JavaScript? Do you have an idea?
String. Nobody knows.
I would say this is integer, and this is half. So it's pretty intuitive answer, half. Yeah? So JavaScript can do this division nicely and just provides answer half.
Sometimes it will be string, sometimes it will be.
So that's the problem with JavaScript. No one knows what it will be. Yeah, the rules are so tricky. That's why JavaScript is dynamically typed and definitely it's not strongly typed. So we can cast between everything and it all happens in the runtime. And then we have Groovy, which can be dynamically typed, so it won't prevent us from compiling these codes. Yeah? So we can try dividing integer by string, and by default, it will start running, but IntelliJ, before running, would warn us. Yeah? You are trying to do some very stupid thing. You are trying to divide integer by string, and most likely it will fail during runtime, so are you sure about it? So if you ignore these warnings, it's kind of up to you, yeah, if you take this risk. If you don't want to have such problems, just do not ignore warnings. Well, if we want to have like full type safety, if you won't stop people from doing such mistakes, if we do not trust them that they will keep those things, then we can annotate with type checked, and then it will behave exactly as same as in Java. It would just doesn't compile. Then Groovy is created to work with Java. So you will be Groovy developers just after this talk. Because the only thing needed to start coding Groovy is to know that 99% of Java code is valid Groovy code. So you can just rename your file from Java to Groovy, add Java and the Groovy compiler to your build tool, and you start Groovy. As these Groovy specific things could be introduced over the time. You don't need to start with those. You can write Java first and then learn thing by thing and introduce those to your code. Then we have many useful things that are painful for Java developers. I won't go into the details. You can read about what cool features Groovy has in addition to Java that simplify the coding. It has natural syntax for maps and lists, which is missing in Java, and even they said that in Java 9 there won't be such syntax. There will be some static factory methods for maps and lists that are immutable, but you won't ever get such syntax in Java, and Groovy has it. It's a pretty natural one. We have math that is precise, so no more 0, 9, 9, 9, 9, 8 answers from simple subtraction. 3 divided by 2 is 1.5, not 1 as in Java. Primitives don't exist, so Groovy is more object-oriented language. So one.class simple name returns just integer. In Java, it wouldn't compile. So there are many additions to that language that makes it more cool. And most importantly for our purposes are that syntax is optional. Many this syntax that was seen in this JUnit test could be totally skipped in Groovy. They made it optional, so you can use it, but you can omit it. So semicolons are optional. When parameters are provided to the method calls, parentheses can be skipped, as it is unambiguous that you want to just call this method with those parameters. And even dots could be skipped when methods are changed. And in result, this could provide us sentences, like English readable sentences without any additional syntax that is stopping us to read those exactly as it was plain English. So if we order coffee with, and with milk and sugar, we could write it without parentheses here, without dots. Just comma needs to be there, but this is also a comma that would be proper punctuation in English. So we get those nice results. For example, we can check that Groovy is readable in very readable way. So here we provide the map of parameters. So this would be the map syntax. So we provide to method check parameter as parameter map that has key dot and Groovy as a value. Then we can chain methods. Method is then readable again proper English sentence. Then I can speak to JBreak saying Groovy is awesome, also in this very readable way with the proper punctuation. Can you see it? That's valid Groovy code. That would be the Java version, and this is just Groovy. Much better, much clearer. This noise is limited very much. And then we have Spock framework that is just built based on the Groovy. It leverages all the features that Groovy brings to us, and it can be used to test any JVM application we wish, so most importantly Java ones. Already it's in version 1.0, so it's out of beta. And you may wonder why Spock name, and Petr Niederwieser, author of this framework, says it's just connection of spec and mock, and it doesn't have anything with this guy, so it's just coincidence. First of all, what Spock does is redefines the language. So we do not never speak about system under test, we rather speak about system under specification. So there are no more tests in Spock, those are specs. It has all the features of Groovy. It is really easy to learn, same as Groovy, because it is based on JUnit. So if you know JUnit, it's just different syntax, more powerful things, but underneath it's just the same. And there are no special APIs. So no special API for mocking, no special API for assertions. Everything is based on operators. Moreover, we don't need to provide any annotations as in JUnit. So there are very good defaults that they just take the class with methods and those are interpreted as tests without any additional annotations. We have very detailed failure information, so we get full context what exactly went wrong. So it's not only information that, in this case, even AssertJ, the cool assertion framework, would tell us that 3 was not equal to 2. That's the only information that could AssertJ provide us. If we use assert true from the JUnit, it will tell us that true was not equal to false. So those assertions provide very poor context, while Spock takes entire line and then it displays toString of every participating object in the assertion and displays the evaluated value of that expression. Then Spock puts a lot of focus on specifying behavior. So it's entire new testing language where this amount of additional things, additional decoration is minimized. So we can focus on what we want to verify, not on all the other things around. And it's suitable for all kinds of testing. So I was talking TDD and BDD and generally idea of JUnit, and extreme programming was not about unit testing. It is about all kinds of testing, so TDD, BDD, unit integration, test last, test first, component system acceptance, all of that can be done in Spock without any additional dependencies. So when I see dependencies in the majority of projects I work with, I see the huge list of Hamcrest, AssertJ, JUnit, Mockito, catch exception, and so on, while we could have just Groovy and Spock, and that's it, what we need for all kinds of testing, really. You don't need anything else. And this is how it looks. So we have class that is name of specification, and it needs to extend specification base class for our each test. Then our feature methods are our tests, yeah, where we execute the scenario. And we could provide any name for those scenarios. So it could be any Unicode name, which is a huge advantage over JUnit because we don't need to encode our scenarios into camel case. We can provide the natural name for those. Now I have a quiz for you. Does it compile in Java? Is this valid Java code? Some people say yes, but the majority is not convinced that it compiles. So maybe this would help. This is a screenshot from IntelliJ. And we have warning here saying that it is unused label. And what are labels? These are forgotten Java feature that is kind of Java go-to statement that enables us to escape from the loops. So if you put a label and it is not used, it would warn us, but it is language feature that Spock framework really leverages. And of course, this is just comment, yeah? Those double slashes are good comments, so this is ignored, and that's why it compiles. But Spock uses those just to indicate the section in the test. So we put given, colon, and there things there have different semantics. They are setup code, when, then, and where are just parameterizations for the test, which are optional. And we can also make it shorter with expect. Yeah? So when, then could be made into expect step where we do both actions and assertions. We could use Spock for data-driven testing, as the tables known from JBehave to parameterize our tests are like native for the Spock. So you may think, how the hell it compiles? And in fact, this is valid Groovy code. So Groovy is so powerful that this is valid code, and these are just binary ORs. Yes, and Spock interprets it as a table and provides those parameters into that method. So a lot of Groovy magic used here. So in fact, it is a specific language for Spock just to run the tests. So it's code that has very special meaning, but still it is code, so all the refactorings, all the nice things we like from IDEs work there. It can also provide these parameters in the method names. It's called unrolling, where we could parameterize our test names with some parameters that were provided. So it enables us to see on continuous integrations that if something fails, it was invoked with those parameters, and it failed because of it, so we have very detailed failure information. So this is a huge advantage over the classical Java testing frameworks. And we have mocking API that is based just on operators. So I won't go into details here, but for example, the Spock uses the proper test double conventions. Unlike Mockito, we have, for example, stub that it's meant just to be recorded. In Mockito, everything is mock, while here we have the proper distinction. And we record mocks, we say about cardinality of method calls, we say about method constraint just using operators. So that's really great how it works. And you may like it or not like it, but it's pretty powerful. So I recommend you going into that stuff. And then Spock really helps us to provide also very readable titles for our specs. So we could have annotations saying that this is easier to read than camel case name of the class. We can annotate things with subject, meaning that okay, this will be tested in this specification. We could have narratives that are annotations and multi-line strings that enables us just to put more whys into each test. Not only this higher level test, but we could put those also in unit tests, which you may find also really valuable for your projects. Then we have additional annotations introduced in Spock 1.0, like issue, C, just for better traceability. We have test first support. Unlike JUnit, you can annotate not yet implemented, and then it would pass only if it fails. So whenever we implement something, it means that notifies us that we are done and this annotation should be removed, unlike ignoring JUnit, that we may forget and leave it always ignored. Then we could very easily test the failure conditions without additional libraries. It's just thrown syntax. So we make assertion by thrown keyword and provide the class name, and it works out of the box. We can also have textual descriptions. So each step can have string that describes in business language what this test is supposed to check. And those you could connect with the JBehave lines with its plaintext. So we could transfer those JBehave descriptions from a separate file into the same file. And those would be just strings that are placed after the labels. So at this point, we may totally resign from JBehave and have the equivalent where the code is just underneath those plaintext specifications. And we can have reports out of that. So I found 2 open source libraries that generates pretty nice reports out of those descriptions. So what those reports do are just taking away the code and they're leaving just this juicy business language from those tests, and they present it to anyone who's willing to analyze those. Then we can even generate markdown from those. If you like GitHub pages and we want to have it presented in a nice way, we could use those. And if we want to use even more smarter way, if we don't want to duplicate ourselves, you could try to write the code in more readable way. So instead of providing these textual descriptions, you could write our code in the way it is self-explanatory. So here in this example, I'm trying to use code that uses this optional syntax just to make it almost like a language. Yeah, so for example, system method receives and the parameter message, but as it is without this parentheses, without semicolons, it is pretty readable. So even non-technical people could have a clue what this test is about at this point. And at some point we noticed that we could even more. So we invited our own domain-specific language just to make those tests look exactly like they were written in JBehave. So the previous level is pretty similar, but it's still a bit technical. Yes, we have some method invocation, we have some dots, it looks technical, but then we managed to convert it into those. And this is still Groovy that looks exactly like JBehave. So here are the assertion, and this is series of methods calls, chaining, and method parameters. And underneath there is domain-specific language that just interprets each of the line with the type safety and executes those, and we don't have any duplication within that way of specifying things. And this is how it looks in the real life in IntelliJ. So we have parameters to the methods, and assertions would be shown when the failure happens. So if the report status was different than n, we would have great insight into what was wrong. And this is how it was in JBehave. Yeah, so this is JBehave plaintext, and this is valid Groovy code. Very, very similar, but this gives much more possibilities, like, for example, static analysis that could be used, because this is just a code. Every kind of refactoring works there, out of the box in IntelliJ, and a lot of fun. So our developers at this point started to love writing specifications, as they had a lot of fun with creating their own DSL. They were writing code, not plain text, and actually started to really live at this point. Then we took those specifications with narrative, with titles, with nice like proper sentences describing what is tested there, and we started to generate reports. So such Spock test was just converted into Confluence page. In our case, for analysts, the Confluence was used for communication, and we are generating out of our test suite Confluence pages with the current description of the system that would never lie. And this was the clue here to make this magic happening between analysts and us. So we started to notice that what they missed in JBehave was nice formatting, colors, kind of possibility to extend some part, yeah, some moving elements here, and nice syntax coloring. So the colors were the clue to communication, yeah. So those are simple people, those analysts, yeah. So they like some beautiful layout, and they started to ask the questions about it. They started to really work with us, and I have really noticed that BDD started working for us really well. So it is possible. It is possible definitely to introduce that in product. It requires just some smart way of presenting it, and everyone needs to like it. Yeah, that's a thing. Both sides. So a couple of thoughts to finish. Do not let intent to be lost in translation. So whenever you have possibility to decrease amount of layers in your tests, just remove some layer. So as we did in JBehave, we didn't have this additional layer of plain text and glue code. We just have pure like domain-specific language in that was executed. Then DSLs don't need to be widely acceptable. So you can create your own domain-specific languages for your own purposes, and it doesn't need to be anything special given from outside. You can be author of your own. You can create living specifications even if you, developers or QAs, you are doing it. You don't need to write those by analysts in order to make it living. And please leverage the goodness of the tools, because the tools are these days really smart, magic, and they help with a lot of things. So why stay with the JUnit from 90s? Let's use Spock that gives so much possibilities. Just do not forget that the projects may succeed despite very bad tools. So even if you use JUnit for everything, you may still have super successful product. And you may fail totally with your project even if you use Spock or any kind of BDD tool, yeah? And the most important testing tool is your mind. So keep it in your minds. Thanks a lot. And now we have time for questions.
Thank you. Hello, my name is Alexander.
Hello.
If I right understand you, Spock is developed and supported by Luxoft. No?
It was not developed by Luxoft. It was developed as open source project by Petr Niederwieser.
Open source project. Okay.
Yes.
And I have some questions. What companies use now in production this framework for testing?
I think a lot of companies. It's too hard to enumerate, but
maybe some big you can name.
I don't think the companies like explicitly state, because it is not used in production. This is testing tool, yeah. But whenever development team wants to test things in Spock, they can use it.
I mean, in some big projects, maybe where it's used for testing.
So I don't know anything outside the Luxoft, but I know that it's heavily used in Luxoft. In our teams, like many teams use it, and they are happy.
And next question about performance. Do you measure performance in comparison with JBehave?
Yes. So JBehave tests usually are system level tests. So the time needed to execute the test itself is usually like small fraction of the time needed to execute entire test, because these tests are executing entire system end to end. Yeah. So usually those end-to-end scenarios, they are just sending some messages, some calls, and they are expecting answers. So the performance is pretty comparable, I would say. Maybe there is something is, I know, 50% faster or slower, but it doesn't matter to the overall performance, as those tests are supposed to be end-to-end. And if you mean unit tests, yes, Spock has overhead over JUnit, so it is slower than JUnit, but it is still not like 100 times slower. Maybe up to 10 times slower, but only the test itself, yeah? The code test underneath, it's another thing, yeah? So if you have tests that are lasting, I don't know, 5 milliseconds, yeah? So if you take the test that is lasting, I don't know, 1,000 microseconds, yeah, so it doesn't
But if you
matter.
have 1,000 tests,
Yes, maybe there are bits like slower, but we haven't found it an issue
okay,
in our
thank you.
projects.
How do you integrate with Confluence? Is it open source or something appropriate? And is it online integration or through files and manual insert?
Yes, that's a good question because I haven't spoken about it. So we paired for half a day and we wrote our custom converter that was suited to convert our custom tests. So it's not open source. We did it for our purposes very quickly and the results were great because it was suited for our needs. So we just took the Spock files and we thrown away those syntax that still remained in those Spock files. Then we formatted it well and we uploaded to our Confluence. So it was 100 lines script. So we haven't published it anywhere, but you can write your own. That's super easy. Absolutely no magic there. But if you want some proper solution, those I showed you those reports, and those reports also can generate any syntax you like because they work on templates. Yeah, so you can have Confluence template or Markdown template or PDF template, whatever you want, and you can just specify what you are interested to see in those reports and publish it. So there are open source libraries just to generate reports out of Spock. Yes.